All right, so we're going to look at playing a couple little games and looking at probabilities and looking at sample spaces again today. So example 1 asks you to compare the theoretical probabilities of the events from the Apple Lottery with the experimental probabilities you found. So 2 days ago, what's today, Friday? Wednesday, you guys did 100, you played the Apple Lottery 100 times.
Yep.
And you compared your theoretical probability to your experimental probability. So what did you notice? Was your theoretical probability the exact same? Was it really close, or was it extremely different?
It was close.
It was close.
It was close.
I feel like it was really close.
You feel like it was really close? All right. So the experimental probability is close to the theoretical probability. Example 2 asks, how do the pairs of numbers you select for the Apple Lottery ticket affect the theoretical probability of winning each type of apple? So when you choose numbers, does it affect what should happen?
No.
No.
No, it doesn't. If you noticed on yesterday's assignment, we played an Apple Lottery 1 through 5, and I asked you to choose 2 numbers. We all ended up with the exact same results, even though we chose different numbers. So,
Wait.
the numbers we choose do not affect the theoretical probability
So does that mean, like in the real lottery, that no matter what numbers you pick, you have like no chance of winning?
Yep.
Pretty much.
Your
So-
chance doesn't change.
Your chance
What-
doesn't change no matter what number you pick.
Right. What changes is the more, yeah, what changes is the more tickets you buy gives you a few more chances of winning, because instead of just buying 1 lottery ticket out of 1,000 that are being sold, now you've bought 5 out of 1,000. So that changes your probability of winning, but your numbers have no bearing on the outcome. Judging from the theoretical probabilities, how many apples of each color do you think you would win after playing the Apple Lottery 500 times? So, we could win 3 different types of apples. We could win the red apple if we had how many matches?
0.
0.
Green, isn't it?
And that probability was 6 out of 15. We can win a green apple if we have how many matches? 1. And that probability was,
Wasn't it?
5.
it's 8.
8.
Yep. And then the yellow,
Must be 2.
yes.
1 out of 15.
Yes, and that one was 1. There's only 1 time that you could win out of the 15. So if we play the Apple Lottery 500 times, how do we determine how many apples of each color will win?
Multiply it by 500.
Yes, multiply it by 500. So we have 6,
6 divided by 15.
yes, 6 divided by 15 times 500 gives you how many apples?
200.
200. So you should win 200 red. So for the green, 8 out of 15 times 500.
266.
So let's round that to 267. And for the yellow, about how many should we win?
33.
33. In a football game, the championship is on the line. The game is tied and the kicker will decide the outcome. During the season, he made 2 out of 3 kicks from this distance. One way to simulate the situation is to use a spinner as shown below. So what's the probability that he makes the kick?
2/3.
2/3. And what's the probability that he misses it?
1/3.
1/3. So what does one spin represent?
One kick.
Very nice. All right, B says use a paper clip to simulate the arrow on the spinner. If the pencil lands on a boundary segment, spin again. So I'll show you quickly how you can do this. You put your pencil at the center here. Put a paper clip right here and spin it like that. So this means he would, what would happen? He made it. So, on the back, let's record. The first one, he made it. Now, if you go to my website, there's a cool application here. When you look at experimental probability, there's an adjustable spinner. So if you don't want to deal with the hassle of a paperclip, you could go.
Such a hassle.
What?
I said that's such a hassle.
It is such a hassle. Well, do you all have paper clips at home?
Yeah, I do.
Do you?
Yeah.
What do you
Okay.
use to clip paper then?
All right, so if you make this, you can make this adjustable spinner. How many sections do we have?
4.
How many sections do we need?
2.
2. So you reduce the number of sections
To 2. I get it.
to 2. Now, on our spinner, what was the probability of one of the sections?
1/3.
1/3, which is what percentage?
33.
0.33.
Yes. So that makes the other section what? 67.
Oh.
All right, so we've updated it because I said I want to change it from 33 to 67. You spin it.
He
Made it. So Mark,
That is good.
make another tally that he made it.
He's just going to make it every.
He missed.
Now he's going to.
Oh, he missed.
You know, every 1/3 time. And make it.
Made it.
Make.
Made it.
What do you know? Make miss.
Did he miss it?
Oh, he missed again.
Aw,
That's a
that's
failure. What a disgrace.
This spinner's unfair.
Now he's just going to make the rest.
Made it.
No, he's going to miss.
Don't.
He's going to make
Another high note.
Yep.
Made it. Okay.
There's no beating the system.
There's no
He
way.
played That sounds like a good idea.
Miss 3 times.
All right, so the experimental probability of him making the kick, how many times did he make it?
He made it 7 out of 10.
7 out of 10. What percentage does this give us?
70%.
70%.
And you guys told me that 2/3 is equal to 66.6% repeating.
Equals.
And you told me that the 1/3 was 33.3% repeating. So theoretically, he should have made it 67% of the time. Experimentally, he made it 70% of the time. So compare them.
It's close.
They are close.
They're pretty darn close.
If you
So
had
experimentally, we figured, or we found that he has 70%, and theoretically, he should have had it 67, so they are close.
If you did 100 times, it'd be closer, I bet.
You're right, and you know what, we're actually gonna look at our 100, playing the Apple Lottery 100 times and look at how close our data actually is to what we should have come out with. Alright, sample space. Example 5. Describe the sample space for each of the following situations. So sample space is the what? List of
The list of
Possible outcomes.
possible
All the
outcomes.
possible outcomes.
All the possible outcomes. Alright, so a child is in elementary school at Pinckney Community Schools. So in Pinckney, what are the grades that you could be in when you're in elementary school?
K through 4.
So kindergarten,
This
first,
is next year.
second, third, fourth. Yes, next year it could change.
Why would it change?
because it changes.
Because
So,
fourth grade going to go into that grade or whatnot.
Yep, they're looking at reconfiguring.
okay.
Alright, 2 ordinary dice are rolled and the numbers are subtracted. Subtract the smaller from the larger. For example, if one die shows a 2 and the other die shows a 5, then 5 minus 2 equals 3. So, we're trying to find the sample space, all the possible outcomes. So, we have 2 items. So how can we display this data?
Chart.
Yep. So the first die has 1 through 6 on it, and the same with the second one. So you roll a 1 and a 1 and you subtract them. What do you get?
0.
You roll a 1 and a 2 and subtract them. 3 and a 1.
2.
Roll a 2 and a 1. What do you get?
1.
2 and a 2 and you get a
0.
3 and a 2 you get.
1. 2.
Roll a 3 and a 1 and you get 3 and a 2 and you get
1.
3 and a 3 you get.
0.
Roll a 3 and a 4 and you get 5 and 3 you get 2.
I think we'll do it.
Alright, now give me one small list of what numbers you'll end up with for answers.
1 through 10, let's say 5.
1 through
1 through 5. 0 through 5.
0,
That's all.
1,
0 through
2, 3, 4, and 5. So this is your sample space. These are all the possible outcomes.
Yay.
Your assignments in your textbook, and one of the problems asks you to look at the face cards of a game.
Like normal forms.
So I actually have the face cards, and I want